Okay, so in this chapter, in this tutorial, in this video, we're going to take a look at probability. And in a way, probability is very related to the previous chapter of combinatorics, in that when we do our calculations, usually we work out the chance of something happening by counting all possible possibilities. But this is, again, a nice area for a computer because we can use a computer to generate random events for us. And so we can essentially simulate these probabilistic events that we want to see. One of the big things we're going to see here is not specifically related to probability, but it's an area of programming that's very important because what we are able to do is get a bunch of code and essentially replace it by one kind of line that will run that code for us. And this is relevant to probability because in probability, we want to repeat a lot of experiments. And so what we're going to do is we're going to get some code that is an experiment, put that into something that's called a function, and this is it's very similar to a mathematical function, but it's a programming function. And then with that function, we can just repeat things very straightforwardly, okay? So let's get started. Okay, so this is the problem we're considering. We have a token we have a bunch of tokens from a bag, 5 red tokens, 7 blue tokens. And the first thing that happens is someone reaches into the bag, pulls out a token. Once we know the color of the token, the token's put back in the bag. If the token is red, then we select a biased coin with a 2/3 chance of landing on heads. And if the token is blue, then we have a fair coin, so 50-50, okay? And so then we just want to know what is the probability of picking a red token. And that has got nothing to do with the coin, right? That's just picking the tokens. What is the probability of obtaining heads? That obviously does depend on both the tokens and the coin. And then we want some conditional probabilities. So it's an application of Bayes' theorem here, where if a heads is obtained, so we know we got heads, what is the chance that we had a red token? All right? And the main tool we're going to use here is this random library, so which allows us to do random things, or at least pseudo-random things. That's a discussion for another time. So we'll do probability, and we import random. And so what this random library allows us to do is, for example, just get a random number between 0 and 1. And if I rerun that cell multiple times, you can see that number changing. And that alone is more or less all we need to then start doing what we need to do, okay? So the very first thing we're going to do is create our bag. And we could, of course, go, our bag is a tuple, so it's with circular brackets, where we have red tokens. And we could type that all out, but it's a bit of a pain. So instead of using a tuple, what we're going to do is something called a list. And this allows us to essentially do a little bit of algebra on our thing. So was it 5 red tokens? 5 red, 7 blues. And so what we can do is we can say 5 red tokens, and we can add that to 7 blue tokens. And if we look at our bag, we have this bag. Lists and tuples are very, very similar in that they are collections of things. They are iterable. But there are some fundamental differences in that a bag is something you can actually change. A tuple, once it's created, you can't change it, okay? Right, so then looking through here, there we go. There's that list that we've created. Now, the thing we want is to be able to choose from the bag. And so if we do random, and instead of doing random.random, which just gives us a random number, we do random.choice, and we pass it any iterable, it will pick one for us. So random.choice, and random.choice again, and random.choice again, and random.choice again. We get that. The important thing with random.choice is that it's doing exactly what the problem said. You're picking a token and putting it back. So if we look at the bag remains unchanged, okay? There are ways to write code where you would take something from a bag and not randomly take something from a bag and not put it back, but that's not what we're doing here. Now, what we're going to do, because we want to do that random choice again and again and again, we're actually going to write something called a Python function that just wraps that code for us. And so go def to define a function, pick a token. I'm just making sure I have it as the same name. Pick underscore a token, and we pass it a container. And just like when we do mathematics, that's just a dummy variable, so to speak. And then everything indented is going to be the code that runs when we call this pick a token function. In the same way that if we say let f of x equals everything after the equal sign is what the f of x is, here it's everything that's indented, all right? And so we say return random.choice container. And the return thing is important here because that's what the value of calling the function will be. And a very important thing, and this is the type of thing that you need to make sure you do, because for example, you might lose a couple of marks on your assessment if you don't, is to add something called a doc string. I'll just write the same doc string that's here. And now there we go. We've defined that function. If I look at pick a token, it is just a function. It doesn't do anything. However, there is now help functionality available to me on pick a token. If I run that, what appears is just this doc string here. So it's very important to put that there so that it's explicit. And then in the same way that we've already seen other functions that do things in Python, I've been careful to call those tools all the way through. We've essentially created a new tool called pick a token, and we can use it. So pick a token takes a container, and the particular container we're going to use is the bag. And so if I pick a token from the bag, I get a red one, I get a blue one, and a red one. Okay, so that's that random thing that we're going to use. Now what we're going to do is essentially repeatedly pick a token, all right? And so we're going to create a little variable to keep track of number of repetitions. We're going to make that rather big, 10,000. And then we're going to create our samples. And so these samples are going to just be picking a token from the bag for bag in, no, not for bag, sorry, for repetition in range number of repetitions, okay? So what's happening here is range number of repetitions is just going to create 10,000 things. And then for every one of those 10,000 things, repetition will just be the number of that thing. But that's not being used. What is being used is picking a bag. This is very similar. This is very similar to when we used a sum, right? But there we use circular brackets. Here we're using square brackets. So we're not adding the things. We're directly computing the things and creating a list. And so if I run that, and if I take a look at the samples, that is all these 10,000 random samples. I can confirm that we got 10,000 of them. And there we go. And so now what I want to do is I want to, in order to answer the question, which is what are the probability of selecting a red one? Is that right? What's the probability of picking a red token? Now what I want to do is I want to go through all those things and find out which ones are red. Okay? And essentially, now I am going to use a sum again, but I'm going to sum over this Boolean, which is going to be whether or not the token is red. And what sum does when it sums a Boolean, it takes true to be 1 and false to be 0. So that's exactly what we want. So we'll go ahead and do that. So what we're doing is we sum over, let me just use the, over sample for sample in samples. But now we set sample equals red. And note that we use a double equal sign. The double equal sign is how we check equality as opposed to the single equal sign, which is an assignment. And to get the probability, we're going to divide by the number of repetitions. That's essentially doing exactly what we want, counting the number of red samples and dividing by the number of repetitions. We get 0.4075. We know that the number of red balls is 5. So the probability of picking a red ball is 5 divided by 5 plus 7. So we're pretty close over those number of repetitions. And to get a better estimate, we would just increase that number. Let's divide it by 20,000. Let's do 20,000. And now if we run it, we're getting slightly closer. And if we did it again and again and again, we would indeed start converging to more and more decimal places. Okay, Now, the next thing we want to do is choose a token based on the probability, based on the token, whether or not it's a red or a blue token. Set the probability of flipping a coin, either 2/3 or 50-50, and then select the coin. And what we're going to do is we're going to use this function to do that. So here's the long doc string that explains what's happening. So the first thing we do is we select a token. So actually here what we're doing is using our other function inside of this function. We're picking a token. If the selected token is red, then the probability of selecting heads is 2/3, else it's a half. And this is your first example of seeing conditional running of code. So this if is inside the code, and what it does, it takes a Boolean. This will either be true or false, and if it's true, it goes into everything that's indented and runs everything indented. The else is what happens if it's false. It runs that. So these 4 lines of code are essentially just assigning a value of 2/3 or a half to probability of selecting heads. And then we're going to flip that coin. And the way we flip a coin with a given probability of giving us heads is we select a random number between 0 and 1 and compare that to the probability. Okay, so that random number will be less than probability of selecting heads with probability of selecting heads. And if that's true, we have the same thing again. We evaluate that the coin is heads, otherwise the coin is tails. And what we return, the value of the function, is those 2 things. That's going to be a little bit to type, so I'm going to go ahead and copy that in. We don't actually need that random import again. We've already used random, so there we go. And then as before, running that does nothing. It just creates this function, sample experiment. We can read the help for it if we want to. And now what we're going to do is we're going to use it. Oh, let me show some examples. So if we just run sample experiment with our bag, we got a red token and the coin went heads. And if we do that a couple of times, red and tails, red again, blue and heads, etc. So what we want to do is now repeat that. I just want to make sure I'm using it consistently. And so what we're doing is we're creating our samples. We sample the experiment where the bag is the bag for repetition, number of repetitions. All right. And if we run that, just as before, and look at samples, samples is now a list with a bunch of these 2 tuples: red token, heads, blue token, tails. And the question asked us, what is the probability of obtaining heads? Okay. And so what we'll do is we'll just go sum over, and again, I just want to make sure I'm being consistent. Sum over, and this is the nice little notation that we can do here, is we can say we know we're getting 2 things out of the function, a selected token and a coin. So we can have 2 dummy variables, so token and coin in samples, where the token would, for example, be blue and the coin would be heads. But we don't actually use the token, we just use the coin. And as before, we compare that to whether or not it's heads. So we do the sum of coin equals heads for sample for token comma coin in samples, and we're going to divide that by the number of repetitions. And if we do that, we get that the probability of getting heads is 0.57. We can, of course, work out what that probability would be, because it's the probability of picking a red coin multiplied by the probability of getting heads if it is red, plus the probability of picking a blue, did I say coin, token, multiplied by the probability otherwise. And there we go. We've gotten pretty close to that estimate. Okay. What I do in the tutorial is I do it symbolically first to get 41/72 and then get the numeric value of that. Okay. What we're now going to do is answer the rest of the question, the last part of the question, which is if heads is obtained. So what we now need to do is conditionally to take a look at all our samples, which are all here, and only consider the ones that have a heads, okay? So we're just going to iterate over all of these, but only use the ones that have a heads. And this is similar to what we did in the previous chapter. The way we do this is we just use the very common mathematical notation of that if, okay? So what we're going to do is we're going to create samples, with heads, and that's just going to be the token and the coin for the token, comma, coin in samples, and then we have an if the coin is equal to heads. So I made a mistake there, which is good. Yeah, you can see it there. It's saying there's a name error. Name coined is not defined. Some of you might have even noticed that as I was typing it. Obviously, my slight error there. And if I just get rid of that D and run it. And now let's take a look at this, samples with heads. We see that all of these are heads, but some of the tokens are red and some of them are blue, okay? And so now we just want to count the ones that are red, I believe. Is that the question? Yes. And so we do that as before. We go sum of token equals red for token, comma, coin in samples with heads. Oh, so this is another good error. It's pointing at the 4, right? But there's nothing wrong with the 4. The error is here, and Python is kind of reading through and going like, okay, I see what you're doing here, but then this doesn't make sense. Because I'm saying assign token to equal red, and then that's followed by a 4, which doesn't make sense. So that needs to be a double equals. If we do that, we get 5,482, but to divide the probability, we want the length of samples with heads. We don't want the actual number of repetitions. We want out of the ones we have where the coin was heads, how many of those gave us a red token? And if we do that, we get 0.48. And in the tutorial, what we do is we just use this as an application of Bayes' theorem, and we compute that the number is relatively similar. And that's what we're doing here in this chapter. And that's how using a computer to study probability can be very useful, because we can essentially let the computer simulate these random events in the first place, right? I go into classes and do some in high school classes and do some outreach work where I get students to roll dice and things like that. And, they'll maybe roll the dice, I don't know, 10, 20 times, and we use that to approximate a probability, okay? Whereas here, we've gotten it to happen 20,000 times. So after doing this tutorial, have a look through the how-to section. We talked about defining a function. And so we define 2 functions, one to pick a token out of a bag and then the other to do this whole experiment. How to call a function, where you just use it. Conditional running of code, that's actually quite an important aspect of programming. That's with those if statements. And again, both defining a function and if statements, they have this indented code part that's rather important. Creating a list using a list comprehension, that's square brackets where we're looping over things and creating a list that way. That's called a list comprehension. Adding items in a list, so summing things up. We talked about sampling, both from an interval and sampling a random number. And then finally, something we didn't talk about, but is how do you reproduce random events? And you can do that with a computer because they're not truly random. They just appear to be random. Once you've done that, have a look at the exercises, have a look at the solutions, and then do look at the further information as well. I hope that's all okay. And do work through this, and then you'll have the tools to be able to use a computer to help you study probability.